Good morning, class. We started looking at section 2.6 last time, and we covered a lot of bases. We finished most of 2.6, so we're going to quickly recap, and we're going to move on from there. So, limits at infinity, horizontal asymptotes. The definition basically refers to what is called the end behavior if it happened to go to a specific limit, okay? Vertical asymptote was discussed again, okay? Then the process of finding the horizontal asymptote is to divide by the highest degree term in the denominator in the case of a rational expression. And of course, we have infinite limits at infinity, the end behavior when you don't have horizontal asymptotes. Then all of these questions were discussed. The first one, we divided by t squared, the top and the bottom, the second one by t. And the third one required multiplication by the conjugate. We went through this page again. The first one you plug in, it works out. The second one by the highest value in the denominator is e to the power of t. Part C requires factoring, and finally you divide by the highest degree in the term in the denominator, which happened to be x, or x to the power of. I believe this is the last page we did. Am I correct, class? Could somebody confirm that? We did this as the last page and it's posted.
Yeah, Professor, this was the last page we did.
Thank you so much. I appreciate it, Zainab. Okay, so in short, in this page, what is interesting for everybody to see is what's happening over here, down here, okay? And the fact that square root of x squared is not equal to x. So what is it equal to? Absolute value of x. And therefore it's x if x is larger than or equal to 0, and negative x if x is less than 0. And this is the only reason you pay attention to that is when x approaching negative infinity, class, okay? If it's not, you don't have to worry about that. Now, of course, if you wrote absolute value, the square root of x to the power of 4 is absolute value of x squared is correct, and if you drop the absolute value is also correct, because if you notice now, this exponent is even. So that's fine if you don't put an absolute value. But this one has the exponent which is odd. And that's why when you look at this question, whether we are dealing with x squared that comes out as x or x to the power of 6 that comes out as x cubed, when it approaches negative infinity, then you want to pay attention to that. If x is approaching infinity, there is nothing to worry about. So we are going to move on. This is the synopsis of what we covered. Okay, so you really want to spend a little bit of a time on this to make sure you have mastered. Okay. We want to find the following limits. Starting with this one, we use the limit laws. We separate them into two pieces, the first piece and the second piece. Okay. I hope you realize that the first piece, if you plug in, okay, because it's infinity, e to the power of negative infinity, this guy goes to 0. It's not a problem. But in general, sine or cosine, it doesn't matter, cosine of x or cosine of 3x or 10x. When x goes to infinity, it oscillates. So this piece goes to 0, but this oscillates and doesn't exist. Therefore, the answer is does not exist. So one more time, two pieces. The first piece gives us 0. Why? Plug in. The second piece, the limit of sine or cosine as x goes to infinity, it oscillates, okay? Here's the next one. And notice the same concept that was discussed when it comes to rational expression. This is not. You divide by highest degree in the denominator in the case of a rational expression. In this case, you divide by the highest value, which is e to the power of 3x. So let's divide everything by the highest value in the denominator, e to the power of 3x. One by one. See what happens. The first one gives you 1. The second one, when you divide it, gives you e to the power of minus 6x. I hope you see that. The same thing happens for the denominator. Now, as x goes to infinity, this guy goes to 0, this guy goes to 0. The answer is 1 over 1. And simply the answer is 1. Very straightforward. I hope everybody is comfortable with the concept. Okay, class? So one more time, a quick recap. You divide by highest value in the denominator is e to the power of 3x. You end up here. And e to the power of minus 6x. That means e to the power of minus infinity, which is 0. Okay. Let's look at this piece. And let's see what technique we need to use to come up with the answer. Whenever it involves something like a sinusoidal function, you have to see the context. Sine is always between -1 and 1. So if sine is between -1 and 1, sine squared is between 0 and 1. That's something we have discussed that before when we did the squeeze theorem before, and we are going to do the same thing here. Now, look at this expression. We want to make it look like this expression. What is missing? 1 over x squared plus 1. All right, so let's multiply all sides by 1 over x squared plus 1. We are multiplying all sides by 1 over x squared plus 1. The left side 0 gives you 0. The middle side, that becomes the denominator, the right side the same. And now it's a very straightforward squeeze theorem. You take a limit of 0 as x approaches infinity is 0. You take a limit of the right side as x approaches infinity is 0. Okay. And the middle function by the squeeze theorem becomes also the limit 0. Now, what do you have to do? You have to go through the process. And when you say this is 0, you have to mention the name of a theorem. ST for short, or squeeze theorem. I hope it's clear to everybody. By squeeze theorem, everybody. Okay, very straightforward. Okay. Let's find the limit of tan inverse of ln x as x approaches 0 from the right. You simply plug in essence. And we've discussed that already. ln of 0 from the right, you all remember the graph. Okay. So you can interchange tan inverse and ln. Even if you don't do and plug in, that's fine. Remember, this is a composite function. And so you have tan inverse of negative infinity. Now, what is tan inverse of negative infinity? It has got to do with you remembering the tan inverse, okay? That goes from negative power 2 to power 2, okay? And the restriction that you put on tangent. So because remember, none of the trigonometric functions is 1-to-1. We put restrictions, and the restriction on sine is the same as tangent, with the exception that on sine, you have the end points in the case of the tangent. We don't. And so the answer is negative power 2. So I'm going to refresh your memory about the graph, and it may be helpful. This is the graph of y equals tan x, okay? X equals pi over 2, x equals negative pi over 2. So I hope you see that this portion, if you can use a different color, going down here, right? Towards negative pi over 2. So that's how this answer is the correct answer, because we remember the graph. That's one way to look at it in case. However, I am hoping that it's one of those common arcs, if you will, okay, that everybody remembers that this is the case in the case of a tangent, okay, where tan inverse of negative infinity is negative pi over 2, or remember tan of pi over 2 is infinity. That's one way we looked at it in trigonometry. Tan of negative pi over 2, okay, it's negative infinity. Let me write those, they may be helpful. Let's see. So recall, we say tan of pi over 2 is infinity. Okay, this is bleeding when I use this pen, sometimes it acts up. And let me put it down here, tan of negative pi over 2, it's minus tan of pi over 2. Remember, tangent is an odd function. So negative. That's another way of looking at it. I wanted to make sure that we are comfortable with the concept. So let's quickly move on. All right. In this example, we want to find the asymptotes. And even if you use the old method using, pre-calculus is fine. But as far as the definitions, we can go with the definitions. If you recall the horizontal asymptote, we take the limit as x approaches positive or negative infinity. We look at the degree of the numerator and the denominator happen to be the same. Okay, they're the same. And so therefore, and because they are the same, it becomes basically 2/3. Or you can divide by x squared and say, I'm assuming from here to here, you take your time to prove that. Of course, the proof is division by highest degree term in the denominator, which is x squared. By now, you have enough practice. You do it in a split second. The vertical asymptote, the limit of f of x as x approaches some number, okay, is infinity or negative infinity. And the good old way is you can set the denominator equal to 0. I'm assuming everybody is very comfortable with the factor. When you factor, you get from here x equals 1/3, from here x equals -1, and everybody is happy, pretty straightforward. So finding the asymptotes should not be a big deal. Finally, if we are given a vertical asymptote as x equals 1 and the second one as x equals 3, with the horizontal asymptote as y equals 1, what would be the rational expression or function? Again, there are really infinitely many ways of writing them. Just as an example, okay, if you have a fraction, okay, x equals 1, that means in the denominator you have x minus 1. Okay, so let's actually do it this way. So let's call it f of x or g of x or h of x or whatever we call that, okay. So x equals 1 gives us x minus 1. X equals 3, x minus 3. Because the horizontal asymptote y equals 1, and I hope you see the degree of the denominator is 2. It's x squared minus 4x plus 3. So you need the x squared at top. Now, what is the coefficient? Let me use it. What is the coefficient of x squared in the numerator? Because y equals 1, it's just 1. But let's say y was 5, you would put 5. Okay, so this is one way to come up with the answer. Now, if I put 10 in the numerator, if I put x squared plus 10 in the numerator, it works the same. In other words, if I said this is not the answer, this is the answer, that works fine. Okay, just as an example. Okay, so this is one possibility. All right, so I hope it's clear to everybody. We are going to move on to the last question. Could somebody be kind enough to read the question for us, please, class? I'm sure you're tired of hearing me. Could somebody be kind enough to read the question, please?
I can read it, Professor.
Please.
A tank contains. Go ahead. You got it. You got it.
No, you got it. You can go.
You got it.
Okay, fine. A tank contains 5,000 liters of pure water. A brine that contains 30 grams of salt per liter of water is being pumped to the tank at a rate of 25 liters per minute. Show the concentration of salt after t minute in grams/liter is B to t is equal to 30t all over 200 plus t. What happens as t goes to infinity?
Thank you all. Thank you so much. And thank you for participating. Class, the first part is algebra. We want to prove what they have given us is correct. Okay, so that's the first thing I want everybody to understand. Part A simply says, okay, this is the answer. Yes, show that. Okay. Understand, we want the concentration of salt. So what is concentration of salt? Amount of salt over the total amount of liquid. That's the first thing. Understand the meaning of it. Okay. How much salt we have, how much liquid. Okay. First, we have 5,000 liters of pure water. That's the amount of liquid we have. First, nothing else. Then we are adding. What are we adding? Brine. Okay. Brine has what? 30 grams of salt per liter. Okay. Of water being pumped into. So at a rate of what? 25 liters per minute. So just for the sake of argument, after 1 minute, we are adding 25 liters of brine. And for each one is 30 grams. So we are adding 25 times 30 grams of salt, and we have added 25 liters of liquid. After 10 minutes, we have added 25 times 10 liters of brine. That will be added to the amount of liquid. And 25 times 10 liters has what? Times 30 grams of salt. Okay. Now do that with T. After T minutes, we have 25 times T liters of brine. And multiply that by 30 grams. That would be the salt. So I hope it's clear as to how we arrive at this. And so the amount of salt is 25 T times 30, and the amount of liquid is what we have added plus the original amount. So that's the answer. So we justified it. Clearly, there is a common factor of 25. And this is the answer. So it's very straightforward, class. I hope everybody is comfortable with that. Finally, what happens as t goes to infinity? Take a limit. Now, this is a very simple limit. You divide the top and the bottom by the highest degree in the denominator, which is t. So when you divide by t, I hope you see you end up with 30. So it's a very simple, process to calculate this. What I'm interested in is to explain what's the meaning of it. And I hope everybody pays attention to that concept, okay? That concept being the following. What happens in the long run? No matter how much water we have, since we are adding brine non-stop, if this thing continues indefinitely, the amount of pure water in a matter of comparison to the amount of brine is nothing. It's basically peanuts. It goes away. Therefore, eventually this becomes pure salt. If you add enough brine that the original amount of water, which was 5,000 liters, which is a lot, that's nothing compared to that, this is what happens. All right, class, we are moving on to the next section, 2.7, derivatives and rates of change. And so first, we are looking at the synopsis of what has been covered, the concept of a limit, a one-sided limit. When they are identical, the limit exists. Horizontal asymptote, vertical asymptote, squeeze theorem, the IVT or intermediate value theorem. So this is the synopsis of what has been covered, just to refresh your memory about the previous topic. And now 2.7, derivatives and rates of change. What I want you to notice here is that as you look at this top here, they are all rise over run class, slope of a line known as a secant line. So look at this curve. We have 2 points P and Q. We connect them. This blue line is called the secant line. Okay. How do you find the slope of any line? Rise over run. Okay, so writing it in that format also. Rise over run. Delta y over delta x. Changing y over changing x. Okay, nothing brand new. Now notice what's going to happen as far as the graph is concerned before we move on to this concept of a tangent line. I want everybody to pay attention to various ways of writing it. If you look at this one, class, this is A, this is X. Here's the formula. This comes from here. I hope you see that. You call the first point A, the second point X. So that's it. Now look at this last one. If the first point is A, and then H is the distance, we call this A plus H. Look at the second one. Okay. What else we can do there? We can, so this distance of H is the same as delta X. If you call this delta X, class, this H can be changed to delta X. Again, I'm just showing you they all mean the same thing, slope, okay? If I change this one to B, okay? If I change it to B, you can look, class, if I change it to B, it gives me the last definition. What is my point? All of this referring to the same thing, slope of a line, end of the story. Nothing brand new, nothing scary. Okay. Now what happens? The blue lines are all secant line. Now we are interested in calculus, we are interested in a tangent line at P. And you have 1 point. So how do you come up with this slope? Well, you see the secant line and you move the Q closer and closer and closer to P. As you get closer and closer to P, you get closer and closer to what? To the tangent line. So I hope you realize the concept. So Q moves towards P, okay? You can say H goes to 0 or delta X goes to 0. Or you can say B goes to A or X sub 2 goes to X sub 1. All of them mean the same thing. So we define the instantaneous rate of change as follows. Take a look. Slope of a tangent line is the limit of slope of a secant line as Q approaches P. Okay, if we use this one, this is the definition. The limit of f of x minus f of a over x minus a as x approaches a. If we use this one, we get this one. Equation of a tangent line. This is class, nothing more than a point slope. So let me write that for you so you don't think it's a big deal. You don't even have to memorize it. This is y minus y1 equals m times x minus 1. It's the same good old point slope that you know, class. There's nothing brand new. You don't even have to memorize that. F of a is y sub 1, f prime of a is m, and a is x sub 1. So we are simply repeating the formulas here. And this is m of tangent line, or f prime at a. Okay, very straightforward. By the way, that rise over run, anyhow you write it, it's known as a difference quotient class. I hope you remember that. And what we did in pre-calculus to simplify the difference quotient. So you can, when you want to take a limit and find the derivative, you can simplify the difference quotient and then put it into the limit and finalize the job. Now, we have blown up the previous graph just for the sake of argument so everybody can see. Now, this distance of delta x, I want you to know it's really very small, but we are blowing up the graph so we can see that. So the idea is that Q gets closer and closer to P. The average rate of change, M of PQ, the instantaneous rate of change, slope of a tangent line, okay? So when you have 2 points, you can find the average rate of change of y with respect to x. If you have 1, it's the instantaneous. So these formulas are the same thing, class. In this case, delta x is approaching 0. In this case, x is approaching a. In this case, x sub 2 approaching x sub 1. In this case, h approaching 0. I'm putting various formulas in case you're exposed to it. They all mean the same thing. Finally, f prime of a is the derivative function. I hope everybody's fine with that, okay, class? So let's go look at an example. It's a very straightforward question. We want to find the average rate of change of f of x from 2. Now, the first thing I want you to notice, this, the moment you have 2 points is average rate of change. And in this case, class, you're dealing with algebra. So basically use that. It's very straightforward. I'm going to assume you can do the algebra nice and easy. So we are looking at f of b minus f of a over b minus a. We are looking at y sub 2 minus y sub 1 over x sub 2 minus x sub 1, whatever you want to call that. Plug in 4, plug in 2, do the math. I have no problem with that. That can be done in a split second. You have done this many times before. What about the instantaneous rate of change? There are 2 ways to do that. You stick with one of them. This is more common. That's why I'm going to use that. I'm going to show you also the second method, class. Again, for practice, you don't have to do it both ways. So what is A? Notice in part B, we have only 1 point, and that's the difference, and that's what makes it instantaneous. So even if they don't mention average and instantaneous, when you have 2 points, it means average. When you have 1 point, it means instantaneous. So A is 4. Now, I hope you see that this is the only calculus step, writing it in this fashion. This is your calculus step. Now, all is algebra. What is f of 4 plus h? Put 4 plus h into this. I'm going to assume you can do that, 4 plus h. And then 4. Okay. Now, as far as f of 4 is concerned, you can calculate it, or you can use it. Remember, f of 4 was calculated here, 16 minus 12, which is 4. So you could write it just here because you've already done that, or I'm showing you it. I'm assuming everybody remembers the basic algebra and the fact that a plus b squared is a squared plus 2ab plus b squared. And for that, we should know that 4 plus h squared is 4 squared, which is 16, plus 2 times 4 times h, which is 8h plus h squared. So you need to know that, okay? And so what happens, most everything cancels out, okay? So 16 and negative 16 go away, negative 12 and 12 go away. You have 8h and negative 3h, they give us 5h. 5h. So you have, let's just write this. Okay, you have 5h plus h. So I hope you see it's all algebra, you're simplifying, okay? And so you drop the common factor of h, you're left with 5 plus h, you take a limit and it becomes 5. Very straightforward. I hope everybody is comfortable with that, okay? All right. Let's do this second method quickly, just for practice class. You don't have to do both ways, okay? So this is the definition. And we are going to write f prime of a. What is a? A is 4, everybody, right? Equals to the limit as x approaches a, which is 4, f of x minus f of a, which is 4, x minus a, which is 4. So I hope that's straightforward. Now this is equal to the limit as x approaches 4. The denominator is x minus 4. The numerator was x squared minus 3x, that's f of x. And remember, f of 4 was calculated as minus 4. Now, the hint I have always given you is this. When you have 0 over 0, and by the way, when you calculate this, you always have 0 over 0, sometimes infinity over infinity. The 0 in the numerator is not a problem, the 0 in the denominator is, so you have x minus 4. And you're hoping that will drop, and so the top should have a factor of x minus 4. So you can even start with that, hoping that you have that, okay? And it becomes very clear that you can write x plus 1. They cancel each other, and they give us the limit as x approaches 4 of x plus 1. Notice I'm not losing the limit sign yet. Now that I'm plugging in 4 plus 1 equals 5, the limit sign is gone. And that's important for everybody to pay attention to. When do you lose the limit sign? Okay, class? Whenever you plug in, not anywhere in between. Okay? All right. So that's that. Again, do you have to do both ways? Absolutely not. I did it for practice, okay? So you are exposed to both methodologies, okay? Finding an equation of a tangent line, class. How do you find an equation of a tangent line? Just the way you find the equation of any line, you need two things. You need a pair and you need the slope. Okay, the pair is given. And by the way, speaking of the pair, I want to make sure everybody understands that in case they give us only x, you plug in and we get to the 1. Okay, just in case. At a equals 1, f of x equals x squared, and we are going to use one of those formulas and find the slope. So we use the limit. We use the first one. F of x is x squared. Okay, a is number 1. The x coordinate of the pair is a. So replace it. So you replace the f of x with x squared, you replace the a with 1. When you're here, you're practically done with calculus. Now your algebraic techniques, they kick in and the top can be factored out. And again, remember the problem is x minus 1 in the denominator giving you 0. So you probably have x minus 1 at top. You do, you get rid of it, you get x plus 1, and you plug in and you find your slope. It's pretty straightforward, class. Okay, there's really not much to it. Y minus y1 equals m times x minus x sub 1. You don't have to memorize the formula that was on the first page. It's the same formula, point slope. So y minus y1, which is 1, equals m to x minus x sub 1, which is also 1. And in calculus, unless otherwise mentioned, we always put it in slope intercept form. Slope intercept form, y equals mx plus b, y equals mx plus b. We are done with this, but again, for practice, I want to show you how to find the slope using the second one, this definition, just so we are exposed to it. We know what's A. A is the x coordinate of the pair. Now plug in 1 plus h into the function. And when you want to plug in 1, since it's given to you, you don't have to. The y coordinate is given, otherwise you have to. Now it's a simple case of algebra. 1 plus h squared is 1 plus 2h plus h squared. One of the things that students normally miss is the middle term. Don't do that, class. Be very careful. So 1 and negative 1 cancel each other. You factor out the h from the numerator. It drops and you get to the same answer. Look at this number. The same as this number. And that's all we wanted. We just wanted to make sure we get the same answer, class, okay? Just wanted to make sure that we get the same answer and there is not much to it. Okay, everybody? All right. Let's look at the next example. And in the case of a next example, I want you again to pay attention to the fact that x is 16 or a is 16. If you plug in, you get 4. Okay, you plug in, you get 4. So they may not give us that. So let's find again the derivative function, or then it becomes the slope when you plug in a. Through the process of limit, a is 16. Okay, class. Now here's what I want to make a point of. So this is your calculus step and you're done. Now you plug it in, okay, into the function square root of x. Everybody knows square root of 16 is 4, but just for the sake of argument, I'm going to keep it as that in case, even if it wasn't a perfect square and it was square root of 15, the process would be the same, okay, which means multiplication by the conjugate, class, because you have 0 over 0, okay? And so the conjugate, this negative sign basically becomes positive. And the top, each piece comes out. 16 plus h comes out, 16 comes out. And what about the denominator? As I've mentioned it many times by now, don't do anything, don't. Just write it as a product, because the 0 in the numerator is not a problem. The 0 in the denominator is, you're hoping it drops, and it does, because 16 and negative 16 cancel each other, everybody. Okay, 16 and negative 16 cancel each other. And then you have h and h cancel each other. And that's important, that you pay attention to why you keep the denominator intact. Okay, and so now, notice, class, if you plug in 0 instead of h, this becomes 16. Square root of that is 4. This is 4. They add up to 8. So 1 over 8. Now, y minus y1 is m times x minus x of 1. Y minus 4 is 1 over 8 times x minus 16. I'm assuming everybody can do this. The only thing I want to add here, okay, let me just quickly write. I'm assuming you have no problem with fractions, okay, class? So this is 1 over 8 x minus 1 over 8 times 16 over 2. Then you move the negative 4 becomes positive 4, and that's what you do. Now, here's the important thing I want everybody to remember. It is extremely important, and that is the following. This pair belongs to the original function. So if I put 16, I should get 4, and I do, of course, right? This pair also belongs to your tangent line that you just found, right? That's the meaning of a tangent line. So it should satisfy this one. So put number 16 here, assuming your slope is right, because this doesn't show that slope is right. It shows that you came up with the correct equation of a line given this slope. So if you replace the x with 16, you get 1 over 8 times 16, which is 2 plus 2, 4. Make sure you check the pair with the resulting tangent line. That is really a good strategy to check your work. Okay, class? I hope everybody is clear as to what I just mentioned. Okay. I hope that's straightforward, class. All right, and so the distance in feet is given, the position function or the distance function. S of t is 2t squared minus 5t plus 40, okay? And we are asked to find the velocity from to. I hope you realize this is the basic idea you know. Delta y over delta x, or in this case, delta s over delta t, class. Delta s over delta t, change in distance over change in time. What is that? Average velocity. Okay, you cover 100 miles. Over the course of 2 hours, your average speed is 50 miles per hour, average velocity. Okay, there's a difference between velocity and speed, class. Okay, velocity is a vector and speed is a scalar. In any event, plug in. What do you plug in? 4 and 2. So plug in 4 gives you an answer, plug in 2 gives you an answer, and this is a very simple case. What are the units? Units of the numerator, delta S, that means in feet, change in distance, over the units of the denominator, delta T, the change in time, that means seconds. So I hope everybody's clear how we arrive at the units. Okay. Now, what is the instantaneous velocity? Okay. Even if it doesn't say instantaneous, it just gives us 4. So plug in. And A is replaced with 4. And now you plug in 4 plus H and then 4. By the way, 4 was already done here and 4 is 52, just for the sake of it. So if I put 4 plus H, I get 2 times 4 plus H squared minus 5 times 4 plus H plus 40. This one I could have written, this part I could have written just the number I had here, 52. Okay, so we don't need to do that in case. Now, I'm going to quickly write at top of it what we have. This is 4 plus H squared, class. So this is, let me see where I want to put that, so I write all of this for you. Okay, so this one, 4 plus H squared is 16 plus 8H plus H squared. Now we are going to multiply it by 2, we get 32. Plus 16H plus 2h squared minus 5 times 4 is minus 20 minus 5h plus 4d, and then minus 52. So everything cancels out with the exception of 2h squared and 11h. You drop the common factor of h, and now you replace the h with 0, you get 11 feet per second. I hope it's clear to everybody as to how we arrive at the answer. It is a simple process, most of which is what? Algebra. Most of which is algebra. And I think we've had enough practice with limits that we should be able to handle it. This section and the next section is about the definition, and after that we get to the formulas. But we use the definitions to prove the formulas that we come across, so it's important that you be comfortable. All right. In this case, we are to find an equation of a tangent line for the function given y equals g of x. We don't have the function, it's called g of x. At a specific point, x equals 5, okay. So let me use my laser pointer here. So at x equals 5, if g of 5 is known to be negative 3 and g prime of 5 equals 4. So class, in order to come up with the equation of a line, we need two things. We need a pair and we need the slope. Is the pair given? Can anybody tell us if the pair is given? Anyone? Is the pair given? So
No, just
up,
x.
Go ahead, please, one more time.
No, just x.
It is given, Ethan. Can we, everybody, can we think about how we can figure it out? The pair is given.
My bad. It's negative 3 and 5.
5 and negative 3. So the pair is given. Very good. 5, then x is 5, y is negative 3. So the pair is given. Very good. We also need the slope. Is the slope given? We need the slope of a line. Is the slope given?
No.
Yes.
Yes.
G prime of 5. And that's the idea, understanding what's given. G of 5 equals negative 3, that means the pair is given. G prime of 5, that's m, the slope is given. We are practically done. I assume you can finish it. Y minus y1 equals m times x minus x of 1. And you come up with the answer. And again, just check the pair. If you plug in 5, did you get negative 3? Okay, so that's how the checking happens. That's a good idea, assuming you have the slope correct and the pair. Put it into the resulting equation, making sure that this works. So this was sort of, you know, a twist of a work to see what's given, understanding the concept. G of 5 equals negative 3, we have a pair. G prime of 5 equals 4, we have a slope at x equals 5. At x equals 5, that's what G prime of 5. If it was G prime of 10, that doesn't mean we have the slope of a tangent line. We do have a slope, but we have it at 10. Having said that, let's look at this situation, okay? The tangent line at a pair 4, 3 for some function, y equals f of x. Here's the tangent line at this point. It passes through one more point, 0, 2. Can you come up with f of 4 and f prime of 4? What do you think, class? Can we come up with f of 4? Let's think of f of 4 first. Can we come up with f of 4? Anyone? Okay. Isn't this pair given? So what is f of 4?
3.
3. Beautiful. Now, tangent line that at this point passes through this point. Can we come up with f prime of 4, class? Anybody?
Yes, we can do that by subtracting both y's and over both of the x's.
Thank you so much, Joseph. You have 2 points, find the slope. First of all, f of 4 is 3. Secondly, you have 2 pairs, find the slope. And that's the answer for f prime of 4. So this is not a difficult question at all. It's, the purpose of that is for us to think as far as the meaning of a tangent line is, slope of a tangent line, and the pair that is involved here, x comma y. Okay, I hope everybody is comfortable with this. This is pretty straightforward, I hope. Okay, all right. We are going to go to the next example and the last example for today. Okay, before we do that, I hope everybody is comfortable with this page. It's something to think about, okay, class? Something to think about. This page, we are given the limit. The limit is given. And we want to compare to either this top, everybody, or this bottom one. There are 2 formulas that define f prime of it. We want to compare. So it's by inspection. I want you to know it's by inspection. And figure out what is f of x, what is a. Okay, I hope everybody is clear what we are looking for. Number 1, we are comparing this to the top or the bottom one. Which one do you think we should compare it to? Anybody? Should we compare it to the top formula, the limit of f of x minus f of a over x minus a as x approaches a, or to the bottom formula? Limit
Bottom
of
formula.
Bottom.
Good, good. That's all we want to first figure out, which formula we are comparing. Good. Now that we are comparing that, okay, we want to figure out what is the function f of x. Think about, this is by inspection, class, so you have to think about it a little bit. What function do you think we have, and what is the value of it? And by the way, sometimes it's really not unique, but we are interested in the easiest way to answer this. F of x equals, anybody?
Square root of x.
Beautiful, beautiful, beautiful. And what is a?
Uh, 9.
And notice square root of 9, class. What is square root of 9? See?
3.
So that works. After you come up with the answer, check your work. Because you are coming up with the answer with this inspection, class, okay? You're inspecting. All right, so here's the second one. And I'm assuming everybody understands we're going to do the same thing. We're going to compare to the same thing, okay? We're going to call it f prime of a is this limit, and compare it to the second equation, this one. Okay, everybody, let's do the comparison. So let's give everybody a chance to do the comparison. And think about, and remember, as we did with the previous one, whatever you come up with, then quickly check it, see if it makes sense, okay? So what function we have and what is h? Okay, what function we have and what is h? Any ideas?
Cube root x.
You mean
A function.
not cube root, okay? You mean, remember, okay, what is the value of number 3? What is number 3? 3 plus h, a plus h. 3 plus h, a plus h. So what is number 3? Number 3 must be
The A.
a, agreed? Okay, so that one is out of the picture. So we got the a, and then remember, it's f of a that gives you 8, and this is 2 to the power of x. I hope you see it's 2 to the power of x, and when you replace it with 3, 2 cubed gives you 8. 2 cubed gives you 8. Again, this is by inspection class. It takes a little bit of a time by inspection. By inspection. Okay. Now, if you let f of x be 2 to the power of x and choice of a is 3, you get this one. Okay. And again, we are going to compare it with the same thing, class. Now, can you compare and come up with the answer? What is the function? Okay. Any ideas? When you compare, first easy, a plus h, class, a plus h is minus 2 plus h. Do you see that? A plus h is minus 2 plus h, right? So a must be what? A must be negative 2. And then you have e to the power of negative 2 plus h, that must be e to the power of x. So I hope it's clear. So you're looking at e to the power of x as the function. And this is e to the power of negative 2, that works. This is a plus h. This is minus 2 plus h. H minus 2 plus h, okay? All right, the last question, class. What do we compare this one to? Which one? Which limit? The top or the bottom?
Top.
Clearly, we compare it to the top. That's absolutely right. By the way, as far as the function, I want to make sure we write this function, but this one is f prime of theta instead of x. I want you to know that. But not a big deal. Compare. What is f of theta? What is a? Let's start with the easy one. What do you think a is? Remember, x is replaced with theta, okay? So theta is approaching pi over 6, right? And this is the denominator. So that's your a, very simple. And this is f of x. So this is f of x or f of theta. It's pretty straightforward. It's just a matter of comparison, class.